as you know, now with the time, I'm the chair of the Young EFC. I'm also the organizer of the online career webinar, and I'm very pleased to welcome today Peter Visser, that accepted after convincing to be our host today. I approach him because I find that he has a very nice career path, and I thought that early career corrosionists can benefit from him and learning how he actually choose his career and the company where he worked in, and basically what led him to do a PhD as well so late in his career. And so, yeah, we look forward to your talk of today. There will be as well a Q&A afterwards, so just unmute yourself when you want to ask a question, and so we can have a very nice discussion afterwards. The floor is yours, Peter.
Thank you, Noémie. Very good afternoon, everybody. I will share my screen first. Let's see if all going smooth. You can see my screen now.
Yes.
Right. Okay. Thank you. So my name is Peter Visser, and I'm working as a scientist in the Expertise Center Corrosion of AkzoNobel. And I was kind of humbled, but also honored that people like the Young EFC asked me for this webinar, because I see my career as something which evolved over time. I never have been thinking about it, that it could be special for other people. So let me take you on the journey that I'm in still at the present moment, and share with you some experience, but also why I'm so passionate about paint, but also about science and product development. Right. So I will have a Q&A in the end. So please hold on your questions along the way, and we get further. Let's see if I can get to the next slide. All right. So many people ask me who's Peter Visser. It's been changing, not so much actually. I'm born in the Netherlands. I'm a Dutch national, living very close to Amsterdam, and I already passed the 5 decades in my life, but still feeling young and vibrant. I'm a father of 2, and not married, and I like a lot of things. I like science. I like corrosion, but I also like to brew beer, scuba diving, seawater aquaria, but also golf to take my mind off work. So once in a while, and already many years ago, it started with a background in organic chemistry. I really wanted to be a professor when I was a little boy. I want to be like doing experiments and cooking things, explosions in the laboratory. But with that organic chemistry background, I joined AkzoNobel in 1997. So already 26 years I'm working for the same company. And then there's also the question, how do you keep it exciting, right? I've been working mainly in aerospace coatings, developing aerospace coatings, but like Noémie said, I did a PhD in between or at the same time. And yeah, let me take you on the journey. So you get to meet also, like say, Mr. Lithium, how some people call me. First of all, AkzoNobel. I don't know who knows AkzoNobel, who doesn't. I just let me take you with a few slides about the company I work for and why I'm passionate to work for this company. I'm also very proud to work for this company. I joined AkzoNobel in 1997, and that time AkzoNobel was still a large company with various different businesses, like fibers, like pharmaceuticals and chemicals. Today, AkzoNobel is a pure coatings company, paint and coatings company. We're a global supplier. We supply paints all over the world, in Europe, North America, South America, Asia, and South Asia Pacific. And we have 35,200 employees, just about. It's always changing, as you know. And we have 144 manufacturing sites. There are many different brands also to AkzoNobel. I'll tell you a little bit about there. But AkzoNobel started already more than 200 years ago, right? In 1792, there was a guy who started Sikkens Paint in Groningen, which is in the north of the Netherlands. It was really a startup, right? And this startup really grew out due to mergers, acquisitions, divestments to the company where it's today. However, innovation is really in the core of our company. And we have two parts in the company, more or less. One is decorative paints. So you can recognize that more or less as the paints that you use in and around the house, right? That you can apply yourself. It's a lot of retail business. And maybe you will find one of the key brands that is present in your do-it-yourself stores. We do a lot of in Asia, Europe, Middle East and Africa, and Latin America with this business. On the other hand, we have performance coatings. Performance coatings is really put in various different activities: marine protective coatings, automotive specialty coatings, industrial coatings, and powder coatings, right? But many different businesses are being targeted. So actually, right, from ships to cars to furniture to house appliances to the cans in the supermarket. No, actually, even your telephone. I'm pretty sure where you are now at the desk, one of the something in your neighborhood will be coated with AkzoNobel coating materials. So we have many different brands and a large presence all over the world. And that comes, paint. In history, we always used to say paint is to beautify and protect, to provide identity. However, it's much more. These days, paints preserve our food, right? Paint reduces the urban heat, right? Special paints to keep cities cool. Also, supporting our energy transfer, right? Using our coatings on windmill farms, but also going into the energy transition for batteries, etc. Healthcare, right? Maintaining our operation rooms clean and no infections, but also helping our transport to become more sustainable. Paint has many different purposes. And it's a world of possibilities. Like I said, we have an innovation portfolio. The paint of today is important, but even the future is even more important. So we have four main drivers called productivity, asset protection, surface enhancement, and environmental protection. Right, and they really guide us to bring sustainable, long-lasting solutions to the world, to the customers, but also to the planet. Right. We, of course, we have color as a functionality of paint, but the more and more you get different functionalities. You have corrosion protection, active corrosion protection. You have even sensing, and you go to functional paints like anti-fingerprint paints, soft feel, etc. Right, and also there's a lot of things becoming more digital. However, the future is ahead of us. With the new targets to reduce the carbon footprint, we have to make more sustainable solutions and provide a circular economy in the value chain. So the business of coatings, paints and coatings has a very bright future because we really have to transform the paint and coatings industry. Right, and we work a lot together with external parties under our to Paint the Future brand, and really driving our innovation to functionalize our services and bring solutions to the people. Right, We try to set the standards as a company for paints and coatings, really bring sustainable, innovative solutions, and focusing that the paints and coatings we supply can help safeguard our world, but not only after tomorrow, but much longer. So sustainability targets that we put to ourselves by 2030, lower carbon emissions 50%, 50% revenue of soluble of sustainable solutions, but also using circular use of materials. However, we want to also bring out our knowledge and our expertise to our community, right? So we have a lot of community building practices where we help make areas better for living, etc., providing color to very gray cities, etc., but also train painters. Okay, so far AkzoNobel. If you have any questions about AkzoNobel and what we are stand for, what we do, I can tell you after my presentation, but also a little bit more comes ahead in this presentation. First of all, I want like you to share really my passion for paint. Personally, I hate painting, but I still have a passion. I have a passion for paint. Sounds like a contradiction, but for me, there's so much in paint that it's never boring, and you can talk hours of it without being bored. But first of all, I want to get back. So this is the early 1990s, how it all started. As part of my vocational school, analytical chemistry, I wanted to get abroad. I wanted to go to another university, study outside of Europe, and I wanted to go in the United States on a school. However, that was not possible. It was way too expensive. So I decided at that time I wanted to do my internship. My internship, a 1 or 9 month internship, I had to do for my analytical chemistry school in a company or a university. Professor Joseph Pasek of San Jose State University in the Bay Area near San Francisco. He accepted me. He had a position for me. Even he could pay me a little bit of money, so I could survive. I didn't only have to live on hamburgers. And really, I worked there on the development and characterization on stationary phases of capillary electrophoresis. And there I got in contact with the first signs of organic chemistry, making something else, modifying these capillaries. When I got back after that trip and I graduated, I decided I wanted to go to our polytechnic school at the time, which provides practical education, higher education, and I went to inorganic chemistry. Really into it's very passionate teachers of organic chemistry, and also already after 2 years in that study, I said I want to go somewhere else. I want to go to Midwest in America or even to Australia. And I started to write letters, and many negative answers came at that moment of time. But Professor Kurt Wentrup, he accepted me in his research group, and really working on low temperature capture of reactive species. And he took me under his shoulders for 12 months and really taught me how to do research. And he even let me write my first paper. A lot of help, but it was a great adventure, and I really know it couldn't be better. His department was on Research Road, so right. And so this was really my sign at the time. I wanted to be in research. After that, I went to AkzoNobel. I've been unemployed for 6 months, driving a car for DHL, but um, I started in AkzoNobel in 1997, right, with a job description which is really, like say, you would say sexy, specialist international product development aerospace coatings. I saw it, right? Aerospace, saw rockets and things like that. And after my first job interview and tour to the laboratory, I was so disappointed. There was no NMR. There's no infrared spectroscopy, no glassware. The fume hoods were ventilated tables. What could I tell more? No glassware, only cans, right? And the materials was not really making something out of two. You make something new, but it was really formulating. But I said, okay, no, I was unemployed for half a year, and I said, no, let's take this. Let's take this job and go ahead. And I can tell you, since then it has been a roller coaster. All right. I started the product development. I will get to that. 2 years later, I became Airbus champion next to my development job, meaning I had to coordinate all kinds of R&D materials that we were doing for Airbus. I became a head specialist or a senior specialist in global product development. And in 2007 is really a special year. There, I decided to switch my career to chromate-free corrosion protection. Right, like Noémie said, starting a PhD 2013, almost 16 years into my career. Started a PhD at Delft University of Technology, aside of my job, 2 days a week. And since 2018, I was innovation project lead in expertise anti-corrosion. So I transferred from product development to corrosion science and corrosion protection. And in 2018, I got the biggest reward that I could ever imagine from AkzoNobel, being named the AkzoNobel Scientist of the Year. 2020, this year, I was being named scientist in the expertise anti-corrosion. Right, so it seems like a rather straight line. No hopping, no hopping to marketing or to finance or to project management and all that kind of or even sales. I've been in contact with all, but no, I'm a scientist. I felt a scientist, and I developed that throughout my career. So how could I develop my passion for paint? Right, paint is a very simple material. It's a resin, it's a binder, a polymer, and we fill that with pigments and materials and some additives, pepper and salt, and enough solvent or material to apply the application. Right, so the solvent water is to facilitate the application from the can onto the substrate. Pigments has a function like color or corrosion protection, and the additives are the pepper and salt that we use. And the resin keeps everything together, right? And now is the question, of course, how do we make that interesting and simple, right? And there it comes, right? Paint formulation is a balancing act, right? You want to combine different raw materials together to get the perfect paint that you can apply and which functions and which performs what you want to design it for, right? And there are so many choices, right? It's easy to take a hard resin to make a very hard coating, but to make a hard, flexible, but also chemical resistant coating, that's a little bit more difficult. And then if you take that coating and you are able to apply it on a panel in the lab and it works out, then the next challenge starts. You have to make it in such a way that you can apply it. You can apply it on an aircraft that is nice and shiny, or on a car that it's nice and glossy, right? And there is where the challenge starts. The first 90% on the coating development in the formulation is rather quick and easy, but that last 10% can take years. And if you have something which you finally can apply, then you still have to be able to produce it. So there's an entire process and journey for each product development. And when I started within AkzoNobel, I started the first on the development on a final assembly primer for a large OEM in Europe in aerospace. Right. So I started in AkzoNobel, and within 6 months, I was facing our customer who was already asking me very difficult questions about the adhesion of the primer on the on different substrates. And I optimized in my first year. I optimized that formulation and went into qualification and got the paint flying. Right. And that's what intrigued me. So intrigued me really to make something in a laboratory which you can see in the end being applied, but also fly. And in that sense, I was also always also very um, curious when I would step into an aircraft if my paint was underneath it. Right. So I also developed a structural primer for structural parts in the of the aircraft. But also at that time, it started to itch me a little bit because I could never see my product back on the aircraft. So then I got two other projects. One was a wing coating. So all the wings of the aircraft are coated, and I developed a very special flexible coating. It's not easy to make a or not difficult to make a flexible coating, but also to make a durable flexible coating, which maintains a certain um, like say a certain elongation. That's quite a challenge, and which really need formulating skills. And in 2000 from about like 2004 to 2007, I worked on the first base coat clear coat systems for aerospace. So I finally also have some products on aircraft frying that I saw. At a certain moment, I got bored in my career. Right, I was optimizing a clear coat for the aerospace industry, 0.25% here, 0.25% there, no change. And there is where I made a decision. There is where I made the decision. What do I want to do? Do I want to go into marketing or sales? I like tactical marketing. I saw a lot, had a lot of stuff with our customers. But there I made the decision to go to chromate-free corrosion protection. I was not ready to leave the laboratory yet, and I wanted to do chromate-free corrosion protection. And there is where the other journey started. Right, in 2007, really going towards chromate free. So a new thing, hexavalent chromium is the material to be replaced. It's the best corrosion inhibitor in the world, and I had to find an alternative, and quickly. And around 2008, around that time, I did an invention, and really opportunistic literature search during lunch. I found an article of Professor Rudy Buchheit. He was not professor at the time. He found out that lithium salts provided corrosion protection on aluminium lithium alloys. As opportunistic as I am sometimes, I just tried it out. Quick test, a lot of solidified paint, a lot of troubles, but there was one sample standing out, and that was being recognized as really outstanding and almost as good as chromates at that time. And that started my journey. Because from that technology, that invention, I developed several products. Lithium leaching coatings for active corrosion protection for exterior of aircraft. We developed products for OEM end lines and in maintenance. However, it doesn't sound that easy because the aerospace industry is not an industry that really accept everything very easily. So they wanted to know more. And there is where I made a switch from like formulation based developments. I went to science based developments. I started to really dig into my coatings, start to work with customers and scientific institutions to really understand the let's say the mechanisms and the scientific reasons behind the invention I did, because we had to explain why it was that good. And this was also the time where we decided within AkzoNobel to be or to look for a PhD student to do this work. However, my manager said, Peter, you want to grow. If you want to grow in this company, you need to get a higher degree. And then I said, one on one is two, because why shouldn't I do that PhD? So I just asked, right? I said, it cannot hurt. No is no. I asked. And my manager said, if you can arrange it, if you can organize it, I will back you. And that is more or less how it went. What I was doing at that time as well, and around that time, I will get back to my PhD in a little bit. Um, but I try to quantify corrosion. I don't know if anybody has been judging corrosion panels coming from a salt spray. It's horrible because it's subjective. Um, you only give values of a single blister or anything like that. And I really got annoyed with that, right? So I said, we have to go further. And we started the process on image analysis of filiform corrosion, trying to see the longest filament, but also the area of corrosion and the corrosion kinetics. Also after salt spray testing, really getting the value of corrosion, because the size of one blister doesn't tell everything, right? It's more about how much corrosion dissipates over the panel, and how can you control that, and how can you quantify that in order to make decisions faster and earlier. Also, we try to quantify corrosion with surface roughness measurements. Using white light interferometry, we were able to get a measure really between good and better coatings, looking at the amount of material loss after only a week of corrosion exposure. Right? And also quantify the quantification of active corrosion protection. I spent a lot of time on that, right? To go beyond good and bad, but more about formulation A, formulation B, which is better, and how can we quantify that? And what we found out as well, by going beyond the expectations of our customers and colleagues we were working with, we were much more able to make faster decisions and also develop our coatings much faster. Taking this as well to my PhD. Like I said, my manager said, if you arrange it, I will back you. Right? I approached Professor Arjen Mol and Professor Herman Terrein of Delft University of Technology. I approached him with the question, is it possible? Right? I didn't have a university degree. I had a polytechnic degree. Um, so I know at that time when I graduated, we didn't have the bachelor and the masters. They listened to my story, and more or less within a short time, it was agreed. Only the contract to organize it took a little bit longer, but I was on my journey. I was, um, um, what is it? Tell that in my 40s, and I was going to do a PhD, right? People ask me why. Why do you want to do your PhD when you're 40, right? You see these minions before and after. It's true. It's true. I felt like that before and after, but really I wanted to become an expert in the field of active corrosion protection. I was talking with engineers at companies all over the world, and they knew more about corrosion than I did. So my aim was, I want to be a knowledgeable expert. I want to be a sparring partner, and I got to play with cool instruments, which was much more fun than putting the sticky paint in one jar and then and another jar. And it really was for me about understanding the mechanism, so I could understand what was going on, but also apply the learnings into my new coatings formulations. But one of the coolest things is, and that I could never imagine that would happen, I got to meet my idols. My idols from literature in the aerospace industry, the aluminium um, corrosion community, I got to meet them. And that was so exciting because apparently they liked my ideas, they liked my stories, and they became very supportive. Also, telling me when I was bullshitting, but also very supportive how to continue. And that was really, really, really great. And actually, I was able to leave a footprint because one at the beginning of my PhD, I said, okay, at the end of my PhD, I want to be mentioned by people like Visser et al., etc. Right? And after my very first publication, it went really great. Actually, at the Faraday discussions, if you ever can go to a Faraday discussion seminar, go there. It's like a mini PhD. It's excellent. It was one of the best um, um, conferences I've ever been. But in my PhD, I was able to write, doing it for 6 years, I believe, top of my head, 14 papers, 8 of myself, 6 co-authored, and I wrote a book chapter. Right, I'm in the same book as edited by my idols. That doesn't happen to everybody. But also, what I'm more proud of than only my own work is that I could deliver 34 more contributions to others. Right. Um, and that is very rewarding, that your work is being picked up and that you're being asked to pick up, to help other scientists as well. And what I find very important about my work and about science, to tell the world about it. Also this webinar, right? We should be proud of what we're doing, right? We tell people, but also by telling people, you will get a response and you will learn. Right? Another tip, what other people say, right? Rewards will come with time, right? If you work hard and passionate, you will be recognized in one or another way. You will be recognized and you will be energized for a very, very long time. These type of recognitions are much more worth than a lot of money. Right? If I look back at my career, all right, and I'm supposed to be, giving you tips and tricks and everything like that, I don't know. I went with the flow. All right, my idea got developed by my team. I never do things by myself. I have a team, so you work together with people. I was supported by the company, of course, providing me the resources and to do things, right? And take it to the world to make a difference. And there is where it's important. How can you make a difference, right? I think everybody can make a difference by being passionate, right? But it all starts with following your heart. What do you like to do, right? People ask me, why didn't you go to sales? I'm too honest for sales, to be honest, right? I like science. I like to be, waking up in the morning and being energized to do something, right? Also, I hear a lot that people, you should develop your weaknesses. No, I think you should develop your strengths, because what you're strong in, you're good, right? You should manage your weaknesses because you cannot do everything, right? That you should exploit what you're strong in, but also take control. Don't leave it to others, right? Like my manager said, if you can handle it, do it. My early stage internships in the US and Australia, nobody helped me. I wrote all the letters. So go after it, right? Take control. And even if you are in your PhD, get in the driving seat, because nothing is more annoying that you are somewhere and you want to go somewhere, but other people go the other way around. Connect with your network, right? I was very fortunate to, like saying, you have to be lucky as well, maybe, to be in a research group which was already well known, which made it very easy for me to more or less connect with my idols. But also, don't be shy to ask them something, because those people, those professors, are proud as well, and they're willing to share. Listen and learn to your environment, and do not follow something, some thought or something because other do. And that was one of my most valuable learnings in a discussion which I had with Professor Jerry Frankel on a paper of mine, because we didn't agree on the equivalent circuit of my impedance analysis, right? And no, he couldn't make it physically and the physical model didn't fit the equivalent circuit. But no, I had the argument, but this other idol of mine had this as a reference. He said, don't follow references which you cannot make up with your work, because it's a good reference, right? So set your own pathway, because then others will start to follow you, right? So that is very important. That's why I asked the questions, right? I was not sure what he meant, and on Sunday morning I received my review back on the paper. I emailed Professor Frankel, and I got an answer. And since then, like I say, we have a pretty good contact. That's really fun. But you should cherish your team, your stakeholders, because if you want to win, you win together. You do nothing, everything yourself. Like I said, no, I became Scientist of the Year within AkzoNobel, but there's only one way that I could do that. It's because my stakeholders and my team and the people I work with. You should use also always a sounding board, right, to make decisions, right? No, a sounding board is really nice, especially if they're honest. Don't be afraid of criticism, because you can use criticism in your advantage, and contribute to the work of others, because if you contribute to others' work, they will help you as well. And work hard, but have fun, because if you forget to have fun, life can be difficult. In my early stages of my career, I was lying awake at night about the problems of my coatings, and then I would have my manager and say, hey Peter, it's only paint, right? It's only paint, you will fix it. By those simple words, he put so much confidence in myself to be pragmatic, make complex things very simple, but also keep asking the questions, right? Like I said, winning together. This is the page where you should come to your acknowledgements, but I have so many colleagues and friends, I will forget people. So it's really my colleagues and friends from AkzoNobel, Delft University of Technology, Vrije Universiteit Brussels, and University of Manchester, but also beyond, right? The network has exploded, but the most important is your home, your family, who support you, who are there when you're grumpy or cannot solve a problem, but also when you have the good times. Something my father always said when we would come home late at night, he said, look up at the stars, right? Isn't that special? Right? Then we would walk inside, and you put on the line to this small button, and he would say, that's special, huh? You walk in, you turn the button, it works, right? So he learned me there's no ordinary thing, right? You should be surprised about the smallest things, right? Take nothing for granted, but be curious, right? When Wi-Fi drops now, people are in panic, right? It's normal. It's not normal. And if you approach things like that, I think you can be very, very successful. But success lies in yourself, right? It's not measurable. Some people want to measure success in money or something else. Um, Success is a feeling that you should experience yourself, and it's different for everybody else. So with this, I would like to stop my part of it and give you the opportunity to ask any question that you would like to ask, except for my bank account. Okay.
And talk about your career. I learned a lot. Does anyone from the audience have a question to Peter? Just raise your hand, or just like unmute yourself and you can ask the question directly.
Am I that clear?
Apparently. So I have one for you. So you talked about like your next, or like your last career move was not that far away, but what do you see for yourself in the future? So you're now a scientist at AkzoNobel. Do you see yourself staying there, or what do you expect as a next step, or what do you wish yourself as a next step?
So I wish, there's such an exciting time ahead within in the coatings, paint and coatings industry, but also in the world, right? We have to become much more sustainable, and that means we have to use different strategies, bio-based materials, thinner layers, reduction of all kinds of raw materials that we should not be using. And corrosion protection is really at my heart, right? For me, it's how can I um, as a person with our company add value, and bring a sustainable future in the coatings and corrosion protection, because corrosion protection only gets harder at this moment of time. Um, so do I see myself leaving AkzoNobel? No, I don't think so. However, what I see is a lot of collaboration with different parties, universities, maybe other companies, in order to make it work. And there's so much to do, so much to explore, and there's all right. I don't think I will be bored for the next 18 years, which I still have to work most likely. I wanted to retire at 55, but I love my job so much I will continue. Right.
I see. There was a question in the chat, but before that, I have another one. It's a bit related, therefore. How do you see the change in the field? So you have now to become more sustainable in the paint formulation, but when you started your career and where you are now, do you think that basically the concern or the job didn't change that much, or basically when you started and now you shifted totally the focus of like paint formulation and how basically the field evolved? What do you see the perspective in sustainability? Sure, but do you see as well that it's getting more and more into smart coding?
I will tell it this way. When I started in AkzoNobel in the development of the primer technologies that I did there, um, corrosion protection was not an issue. The hexavalent chromium as a corrosion inhibitor at that time was the standard, and we didn't even have to do corrosion testing or salt spray testing because it would work. At that time, we as AkzoNobel already had a very first chromate-free coating, but it takes very long before the industry adapts that. But luckily, we have many spin-offs from aerospace into other coatings areas. Where I see the biggest change in the future is rather exciting one, I would say. Um, of course, we have to measure much more, no corrosion rates and things like that, smart coatings and things. Um, you can have smart coatings. However, if you don't write the right corrosion inhibitor, then it doesn't work, right? You can have the smartest coating, but you still need a sustainable corrosion inhibitor. And when you have a corrosion inhibitor, then you should start think how you can put it in a coating. However, where the exciting start will be, I think, is around the buzzwords. What is artificial intelligence going to do for us? Machine learning. Um, in history, one would make coatings to pass the test. I will see for the future we will make coatings to fit their purpose. However, if you want to do purpose, you come into topics like predictive maintenance and things like that. That you see also coming up. Um, you see a lot of sensing in the world around us. If you are Eurocore, you see more and more sensing. But no, the very first stage which we have to take is the quick transfer to more sustainable materials. So the chromated chemical conversion coatings are being banned, let's say, and also coatings chemistry will change from solvent-borne to water-based, which will have a major impact on the industry. And I think the field of corrosion science will become only more important in the coming time. However, I think we have to be more pragmatic in the way we do corrosion studies, right? Evaluating a corrosion inhibitor in a 100 milliliter solution on a 1 centimeter sample is nice to say if it's an inhibitor, possible inhibitor, yes or no. But if we are turning around the same corrosion inhibitor 25 years and still do not use it in the industry, why should we continue with that, right? In Eurocore Montpellier, I already mentioned once, well, shouldn't we for once move beyond 2-mercaptobenzothiazole and benzotriazole and try to find other corrosion inhibitors, right? We have to make decisions, right? And we don't have to stay only in the warm water, but sometimes step out to the cold water and step different routes.
Yeah, I agree. So there is a question from Jaren, who has his microphone or her microphone not working. So what was your experience working with Arjen in TU Delft during your PhD?
That's a very good question. Now actually, I should nominate Arjen as the first career webinar. No, the experience was great. For me, the combination between Professor Herman Terrein and Professor Arjen Mol was great. As persons, they really connect, but also they complement each other in the academic thinking and working. So actually, I had a combination of for me very nice, a great team of professors. Actually, on both professors, because if we would only talk about Arjen, I would neglect Professor Herman Terrein. Is the human factor, right? But I must say also in my PhD, I was a little bit lucky, right? I was a little bit older. I would not get nervous that fast anymore for a presentation. I knew what I wanted to do. Every experiment I wanted to do, I had a paper in mind, right? So in that way, more or less had an easy job. However, where they really helped me was on the interface between academia and industry, right? So there are two force fields there, right? Academia wants to publish everything and do everything. Industry sometimes not. However, we had an excellent working relationship, so we got a lot of freedom, good coaching, and yeah, no, excellent guidance. So two excellent professors. I hope that answers the question.
I think so. I will keep on monitoring the chat. Edsel, do you want to ask your question yourself?
Yeah, am I audible?
Yes.
Yes.
Thank you. Apologies, my camera is down. I'm so actually on the home network, so it's not much bandwidth out here in India. On one note, thank you, Peter, for your lovely sharing. I think every R&D person, every person in doing research work from the heart actually would vibe or basically be a soundbox to exactly whatever you said. So thanks so much for that. I come from a market which is very sensitive to cost, but still wants everything. Maybe a little bit different from the B2B segment where you deal with high-flown customers like Airbus and Boeing. The problem that we face in India is that we need everything yesterday. That's point number one. And point number two is that you would like to get at the cheapest possible cost. Now, with the experience that you have in also all the development of corrosion inhibitors, how would you approach a decorative market for a low cost segment with sustainable corrosion inhibitors?
That is a good one. Actually, to be honest, our customers also want everything at the lowest cost, right? It's a relative thing. Of course, at the lowest cost, if you want, you know, there are many ways in formulating your materials, right? Your coatings, right? But no, it's all in the basics, right? It's all in the basics. No, get your coating parameters right? Get your adhesion to the substrate, right? And if you have a good adhesion to the substrate and a coating formulation in such a sense that you have a good barrier, you already have a pretty good coating, right? The problem only starts there, when you have a defect. What happens then? What happens to your interface? And of course, on corrosion in inhibitors, right? If you want to have low cost corrosion in inhibitors, if you have them, you have to tell me as well, because that's also a little bit problematic, right? I see. I see another problem arising in the world, or a challenge, right? It's the new legislations, new registrations about chemicals, right? On one side, it's very good, right? That, for instance, in Europe, we have the REACH legislation, where we limit the use of non-sustainable or hazardous materials. However, in future, we will have to provide corrosion protection with almost inert materials. So we will have to find a way to bring corrosion protection in a sensible way um, to the world, right? And that's one, making better coating by itself that stick better, protect better, have a better durability. However, it's contradiction with biodegradability, which other people will ask from you, right? So we're like, say, in a force field, and every company and every person has to make a decision how to pursue that in the best way possible. So also on that side, yeah, maybe I cannot give you the answer, but I wish you all the best, and just be creative, right? But stick to the basics, I would say.
Thanks so much, Peter. I think I'll be in touch with you shortly afterwards. Thanks.
Paul, do you want to ask your question yourself?
Sorry?
There is Mikael who raised his hand. So do you want to ask your question? We lost Mikael, maybe. Is there anyone else who has a question in between, or yep. Mikael, go ahead.
Hi, Peter.
Hi.
Hi, my name is Michael. I'm from Ecuador, Latin America.
Hi. Thank you.
My apologies. I speak English a little bit.
What is your question?
For you and your experience, which type of coating are more difficult to develop?
Which coating is more difficult to develop?
Yeah.
There's so many different coatings. Of course, you know, if you want to develop at this moment of time water-based coatings, robust water-based coatings for corrosion protection, is a very nice challenge, I would say, right? However, I would not be scared to pick it up. But every type of coating for every type of application has its own challenge. It's its own properties that you will have to optimize, right? And that's why it's never boring, whether if you are in aerospace coatings or in marine coatings or coil coatings. There's every type of coating has its problem, its challenges, and that's what it makes it also so rewarding to solve as a scientist.
Thank you so much, Peter.
You're welcome. Drive
Are
safely.
there, are there any other questions from the audience? If not, Peter, thank you so much for being here today and share your passionate work and career path with us.
Thank you for having me. Right, once again, as an honor. I didn't think my career was that interesting, but it's nice to see that people are interested to see
I'm
it.
so glad that you came and you accepted our invitation. For those of you who I will not see at our other event, I hope to meet you at Eurocore.
We'll be there.
Otherwise, I see you maybe next week, our science communication event. Afterwards, we will have a summer break, but we will be at Eurocore 2023 in Brussels. So have a good afternoon. See you soon. Bye.
Thank you. Bye-bye.